Good morning. For this session, we will discuss distance time graph. So it is a graph of distance versus time. So this is a graph of distance to time. Have you noticed any difference? Which one is the faster? Which one is the slower? So which one have the steeper slope and which one has the minimal slope? So if your answer for the steeper slope is the red one, so you are correct. So it is steeper because it changes position faster than the blue one. So the red car is faster than the blue car. So it's speeding up. That's why it is changing its position. So distance over time again, if we have recall, distance over time is equal to velocity or speed. So that's the rate of position over time. So that's velocity or speed. So if you have a direction, you are computing for the velocity. If you have no direction, you are computing for the speed. Now, our goal for this session, we will represent the motion of an object on a distance time graph and explain the graph, whether it's moving faster or moving slower. Let's see what will happen. Let's have an example. A taxi covers a distance of 20 meters in 40 seconds, and the bus covers a distance of 30 meters in 40 seconds. So how are these motions different? How can we use a graph to present motion? Okay, if you will get a piece of paper, you may pause this video. So let's compute for the velocity of each. So 20 meters divided by 40 seconds and another 30 meters divided by 40 seconds. So if you are not going to compute this, so obviously the bus is faster than the taxi because it already covers 30 meters in 40 seconds, while the taxi only covers 20 meters in 40 seconds. So here is how you graph distance for uniform speed. So when we say uniform speed, it's not changing velocity. So the acceleration is constant. If you are not changing velocity, we have no acceleration or constant acceleration. What's the acceleration here? It's zero. Okay. You are only changing distance over time in a uniform speed. It means that you are in a constant speed also. So you are not changing your rate of speed. You have 50 over 1 or 50 meters per second if we have the units. On your paper, draw the graph of the following motions. So you have 20 meters in 50 seconds, 60 meters in 66 seconds, and 75 meters in 25 seconds. So you could graph this on a graphing paper. You could pause this video for a while and then graph this. So along the y-axis or vertical line, we have 20 meters. And along the horizontal line, we have 50 seconds. And so on. You can do that for yourself. So along the y-axis, we have the distance. Along the x-axis, we have the time. If you have your workbook with you, answer the following um, exercises or activities with regards to the distance time graph. And that's all. That's the end of our discussion. Thank you.